So the topic which I would like to discuss today is about the types of corrosion. Generally, there are three different types of corrosion: galvanic corrosion, waterline corrosion, and pitting corrosion. So first one is about the galvanic corrosion. In case of galvanic corrosion, this type of corrosion takes place when two dissimilar metals are connected together and exposed to the conducting medium. So the metal which possesses higher oxidation potential, that metal has a tendency to undergo oxidation. So when a metal is undergoing oxidation, that metal has a tendency to undergo corrosion at a faster rate. So here is a one example, like I've taken a zinc as well as copper. So zinc and copper are the two metals which are connected together and are exposed to the conducting medium. So here among these two metals, zinc is a metal which possesses higher oxidation potential when compared to that of copper. So that's the reason why zinc undergoes oxidation, liberating Zn plus 2 and 2 electrons. So zinc ions and electrons which have been liberated, those liberated electrons at the anode tends to move towards the cathode. Okay, so at the cathode, the copper is present. So this Ca plus 2 ions tends to react with the electrons, form Ca. So in this way, as zinc metal is undergoing oxidation, the corrosion takes place at upon a zinc metal, leaving the copper metal unaffected. So that is one of the example for the galvanic corrosion. Next, coming to the waterline corrosion. In case of waterline corrosion, we just take a huge tanks. It's a stainless steel tank. It's a steel tank. In a steel tank, to half of the level are filled with water, such that just beneath the waterline, just beneath the waterline, the rust is being formed. The rust is being formed just beneath the waterline, not above the waterline. The reasons for which the just beneath the waterline, why the rust is being formed is the area is poor oxygenated. So that's the reason why this just beneath the waterline, this area is poor oxygenated. Though it is poor oxygenated, that area is that particular metal is in contact with the moisture. So that's the reason why just beneath the waterline, the rust is being formed, and that is acting as an anode. Whereas above the waterline, it's highly oxygenated, and that area acts as a cathode. So as metal, when it is reacting with water, metal, when it is directly in contact with the metal, undergoes corrosion. That's the reason why the rust is being formed just beneath the waterline rather than above the waterline. That is being observed in case of waterline corrosion. Next, coming to the pitting corrosion, the next one is about pitting corrosion. In case of pitting corrosion, here when a metal is being taken and upon the surface of a metal, if we find any cracks or pits or pinholes on a surface of a metal, through that through the cracks or pinholes which are present upon a surface part, through that holes only the diffusion of oxygen takes place. Once the oxygen gets diffused into the metal, thereafter the iron metal undergoes oxidation, liberating Fe plus 2 ions and electrons. So now these liberated electrons at anode tends to move towards the cathode and react with the oxygen and atmospheric moisture, producing hydroxyl ions. So whatever the hydroxyl ions which are produced at a cathode, those hydroxyl ions tends to react with an iron metal forming ferrous hydroxide. So this ferrous hydroxide, upon further reacting with oxygen, atmospheric oxygen, and as well as water, producing ferrous hydroxide, hydrated form of ferric oxide, which is nothing but a rust. So in this way, the pitting corrosion usually takes place on a surface of a metal if it contains any pits or pinholes on a surface of a metal. So that is all about the types of corrosion.